Educator at the Smithsonian Marine Ecosystem exhibit. Thank you so much for joining us for our second edition of Career Dives Conversations in Marine Science. Today, we're doing a very special World Oceans Day edition where I'm going to be sharing a little bit about my background in microplastics and marine debris, and then we're going to be talking a little bit more about microplastics in celebration of World Oceans Day. So this summer series will highlight the career tracks, interests, and projects of marine science professionals working with the Smithsonian Marine Station and Marine Ecosystems exhibit. Make sure you stay tuned every Thursday at 10 a.m. for the next couple ones we're going to be doing. They're really exciting. While people are joining, I just want to say you can use the chat button at the bottom of your screen to let us know where you are, where you're joining us from. And as everyone joins the webinar, I'd like to point out some of the features. You can use the Q&A box to ask your questions to us, and I hope that you do. You can submit a question at any time, and we'll try to get to as many of the questions as possible at the end of the program. Please be patient with us, as there may be a high amount of questions, and we may not be able to get to all of them. There's other educators in the background to help keep track of them, and if you see a message on the chat box, it will be coming from them. Throughout the program, you're welcome to use the chat box to send us messages, but we please ask that you submit your questions in the Q&A. Your comments are visible only to Smithsonian staff, so please keep them on topic and appropriate. This program will be about 40 minutes, and it's going to be live streamed to Facebook, and it's also going to be recorded onto YouTube. So if you can't catch it in person, you can always catch it after the fact. Okay, so that's a little bit about the background, and without further ado, let's go ahead and get started. So let me share my screen with you. Well, hello everyone from Florida. Hello everyone from the UK, from Oregon, California. Wow, we're all over the place. Maryland, Georgia, amazing. Welcome everyone. All right, let's get this up and running. Okay, so again, welcome. We're going to just be talking a little bit about marine microplastics in a bit, but I just wanted to share with you kind of my journey and how I got into microplastics and into marine debris and how I ended up here at the Smithsonian Marine Station. So this is the beginning for me. I love this picture because it's very silly. I'm holding up a snook here. This is a fish in Florida, a very common sport fish. From the beginning of my life, my dad was an avid sport fisherman, and my mom and he loved to go and to take us out in the boat. I was a very privileged Florida child. I got to go out in our tiny Boston whaler and get to play in the Indian River Lagoon and in the Atlantic Ocean and learn how to fish and learn how to just be in the water. And I know that's not everyone's experience. And so I really do appreciate that I came from that background. And it led me to be very passionate about marine science and about our water world. And when I was deciding on where I wanted to go to school, I decided to stay locally in Florida, and I went to Florida Atlantic University for my undergraduate degree. My undergraduate is in biological science with a focus in environmental science. And I had a lot of really awesome opportunities. So I got to be on 2 research cruises. I got to go on the RV Weatherbird, which is it's decommissioned, I think now, but we got to do some really awesome sampling out in the Gulf of Mexico. And as you can see in this picture, I am extremely passionate about field work. I love being out in the boat. I love being out and sampling, even as in this sample is an Ekman grab from the bottom. So this is just oozy mud, but I don't care, I'm thrilled. And my undergraduate work concluded in a poster which was featured at Harbor Branch Oceanographic Institute. And I looked at, with my partner Kenneth, we looked at comparison of water column productivity and fish biomass in the Eastern Gulf of Mexico. So comparing how much fish to the primary productivity, which was the phytoplankton in the water column. And I really loved it, and I left my undergraduate very, very thrilled to continue marine science. I did a couple other jobs and various internships, but there was one particular job that really started my journey on marine science, and that was making jewelry with marine debris. I worked for a company called Planet Love Life, who is owned and operated by my 2 very close friends, and they take discarded or salvaged fishing nets and line, and they turn it into these beautiful, beautiful jewelries. So what I really enjoyed about this was it was a super creative outlet, and it was the first opportunity for me to really start having conversations about marine debris. I mean, you would wear this bracelet on your arm and someone would say, "That's incredible, that looks so cool." And then you could say, "Thanks, it's actually marine debris." And it would start a really cool conversation about why, you know, it's so important to remove these and raising awareness about it. And through this position and through being creative with this company, I really started to hear myself having conversations with people about like, well, if nothing changes in policy, you know, we'll never get some of these issues addressed. And it kept coming up, policy and like making different laws and legislations and policies to enforce, you know, reducing the marine debris that we were finding. And so I came across this really unique program. I went to the University of Edinburgh in Scotland for a master's degree in marine systems and policies. So at the time I was looking, there wasn't many programs that were marine and policy. There was terrestrial ones, but they weren't specifically focused. And I moved from Florida to Scotland, which was a very different experience. And I'm so glad I did, because I had an amazing experience. I like met a lot of amazing friends here. And I ended up getting my master's thesis published, and I got to present on that in this picture here. So what's really interesting, I think, is when I started my master's, there's a recording of a conversation I had with my supervisor where I said I didn't want to do plastics anymore. I had been really passionate about it in my private life and my personal life, and I was like, I don't want to talk about it anymore. And then just through like a series of conversations, I ended up back in plastics. And I did a historic baseline assessment of marine litter in a deep water marine protected area off the coast of Scotland. And it was really cool. So a historic baseline assessment is just like looking at all of the previous recordings that we could find. And that was cruise reports and remotely operated vehicle footage. And I also did some benthic dissection. So I looked in tiny invertebrates in the area that were brought up from the sampling, and we digested them using enzymes to look to see if they had ingested any microplastics or microparticles. And this is what this picture is here. So this is actually a polychaete worm that had been preserved in industrial methylated sulfate, so IMS. And this blue, I hope you guys can see, this is actually a microfiber. And we're going to talk a little bit more about those in a minute. But as I said, this work is published. It's open access. It's on Frontiers for Marine Science if you want to have a look. And I hope that you do, and I hope that you enjoy learning about it. But so I was in Scotland for a little over a year, and then I journeyed back to Florida, and I did a couple different internships, and then I ended up at the Seattle Aquarium. And this was really fun because this was my first foray into microplastic research. I was a microplastic research assistant, and I was helping them develop their project, where I got to talk a little bit more with experts. So this picture is a really unique opportunity. In collaboration with the Seattle Aquarium, we got to host a microplastic workshop where we invited a lot of the key researchers in the Pacific Northwest to come and to talk about their research. So they came to the Seattle Aquarium. They came to from all over the Pacific Northwest, and we all got to talk about standardizations, about what that's looking like, and where everyone's at, and to help each other grow, because there's so many things that need to get addressed. And if you're just trying to reinvent that wheel every time, it can be exhausting. But if you collaborate with other researchers, you know, you can get through those hurdles a little bit quicker. So I noticed a really quick question. I just want to take a break from that and address it. So the bracelets, what do they stand for? As Sarah asked, they are just a piece to raise awareness about marine debris. So those bracelets are a beautiful, beautiful handcrafted artisanal jewelry, and they stand for, you know, educating people about marine debris and why it's important. So you can have that conversation. Just someone compliments your bracelet, and then it starts a whole other conversation that you might not have normally had. So that's what those guys stand for. But thank you so much for asking. So let me jump back in to Seattle Aquarium. So here I was in Seattle, very similar to Scotland, and we were doing some sampling in Puget Sound. And we had been finding microplastics in the water. We were sampling the water that was coming into the Seattle Aquarium. What's interesting is that we were finding primarily microfibers. So we're going to talk a little bit more about that. So without further ado, I guess let's just transition straight into how I got to the Smithsonian and how I'm here talking about microplastics with you today. So after my contract finished at the Seattle Aquarium, I applied for an internship with the Smithsonian, and they actually said that they'd like to have me as a full-time educator, which was really great. And so now I'm here as a marine science educator, where I get to talk a lot about some of the issues that are affecting our oceans, and I get to interpret the exhibits here at the ecosystem exhibit. And I'm thrilled today to be talking to you guys about microplastics and having this virtual webinar. So without further ado, let's get into microplastics. Now, there's a lot of really good resources. There's a lot of great information out there, and I don't want to spend too much time explaining like what microplastics are. I think at this point, a lot of us understand that they're any plastic smaller than 5 millimeters. I love this photo because it shows the microfragments. It shows microfibers. It shows little micro beads or nurdles. So you can get a really good idea of what kind of types of microplastics that we're finding when we're sampling these different areas. And the interesting thing about microplastics, as I said, is that there's really two different types, if you will. So primary microplastics are any microplastic that is always a microplastic. It starts off as a microplastic, it starts off very small, and it of course stays really small. And these include microfibers and microbeads. So microfibers are small fibers. They're from clothing most often, and they can also sometimes be from fishing nets, but we find that a little bit more infrequently. Microbeads are small beads that either have been used as an abrasive agent, so something that helps you scrub in face wash and toothpastes and hand washes, or they can also be called nurdles, which are pre-production pellets. And these are things that they're small little pellets that get melted and extruded into different larger plastics. What's really cool, and I want to kind of mention this now, is that in 2015, the United States implemented what we call the Microbead Free Waters Act, and it was a policy that stopped microbeads from being able to be used in cosmetic products. So we'll talk about that a little bit later on, but I did want to mention it here now. So if you're like, well, why are these things allowed to be in the United States in 2015? After that, they weren't allowed to be in the products anymore. And then we also have secondary microplastics. So these are usually just microfragments. They're particles of something that used to be larger. So toys and buckets, plastic bags. It started off as a larger item. And then because of this process that's called photodegradation, it's a degrading process. Like sometimes we use biodegrade, but plastics don't biodegrade, they photodegrade, which means that in UV light from sun, they break down. So if plastics get into the ocean and they're in that wave energy and they're in really extreme sunlight, they fade and get brittle and they'll break into smaller and smaller pieces. They never, ever, ever go away. They just get smaller and smaller and smaller. So those are the two types sort of microplastics that we see and that we find out in the environment. And this is just a little picture to give you guys an example. So the larger plastic waste breaks down into microflakes, microparticles, microfragments. Sometimes they're referred to. Beauty products, there used to be these microbeads. And then from our clothing, we have microfibers. So when your clothing is sometimes made of plastic like nylon or the word is escaping me. They're made of plastic, and when you wash them, they actually break into microfibers, and we're going to talk about that. So you have all these sources of microplastic. How do they even get to the ocean? And it's a really interesting and very complicated process. It's a really complicated journey. So when you're at your house and you're using microbead products, maybe you're washing your clothes in the washer, you definitely want to wash your clothes as often as you need to. But there are some things that you can do, and there are a lot of ways that, these things get to the ocean. So at your house, when you're using water, after it goes down the drain or after you're your washer drains to the sanitary sewer. And this sewer is where all the sanitary waste gets transported to water treatment plants. And that water is treated in a couple different processes over time to get rid of the biosolids, to get rid of the things that are accumulated in there. So this is just like a PSA. Please do not flush anything down the toilet that is plastic. That includes Q-tips, contacts, any of that stuff. Like, please do not put it in the toilet, put it in the bin. Because eventually it'll go to the treatment plant. The treatment plant processes it. Usually they're tertiary, which means that there's 3 major steps in removing matter from the water. And once that water is treated, it gets dispersed into the waterways. And as we know, all water leads to the ocean. So that's how those plastics that don't get treated in the treatment plants, they're very, very small, and they escape through that process, and they end up in the waterways, and they end up in our ocean. The second major way that microplastics and microparticles get to the oceans is via the storm drains. So a huge secondary microparticle is actually from tires. So they're rubber, which is a plastic polymer base. And as you're driving your cars, it creates a lot of friction, and those tires shed little pieces, and that rinses down the storm drains and rain events into the catch basins, into the waterways. There's no filtration usually on those, and then it gets straight to the ocean. So there's 2 major ways from a consumer standpoint that these microplastics get to the ocean. And what does it matter, I guess? A lot of people ask this question, and sometimes it gets addressed, but I really want to kind of focus in and hone in on it, because this is why it's so important, and this is why the conversation keeps coming up. And I really love this infographic, and it talks about the 3 kind of major ways that microplastics impact the marine environments. And the first one, like we talked about, that UV light breaks apart those macroplastics, so they're larger plastics, not like micro, and they get into these smaller particles, microplastics. And they accumulate. Biofouling just means they accumulate microbial biomes, which we'll talk a little bit more about in our innovative research section. They'll sink, they get heavy, and they get into the sediment. And so they can block a lot of processes when they do that. So the physical impact is that they're just there, and the animals and the organisms that would usually be interfacing with these environments now have to account for this physical thing being there that they're not used to, or that is kind of new to them. And it may not hurt them, it may not be detrimental, but it is there, and they do have to kind of adapt around that. The second way is chemical. This is probably the area where there's the most opportunity for research and understanding. Microplastics that float or that are in the water column encounter what we call persistent organic pollutants, sometimes POPs, sometimes they just called POPs. And these are pollutants like fertilizer from runoff, DDT that's still sort of circulating in the environment. It's been banned, but it still exists. Because microplastics are a plastic polymer, and they're oil-based polymers attract other oil-based polymers. And it's really interesting. They're like magnets to each other. So these little floating plastics are actually like absorbing all of these chemicals that are in the environment. And there's one way to look at it, like it's good that they're removing it, but the issue is that once these chemicals leach into the plastic, the plastic gets transported into other areas, and maybe those chemicals leach back out as they degrade, or if they're ingested, and we're going to talk about that now. So biological, which is probably, it's getting more and more understood, which I think is really cool. There's a lot of awesome studies, but plastics are ingested almost at every level of the marine food web now. And it's possible that those chemicals are leaching into the marine organisms, and then if we eat marine organisms, they may be leaching into us, right? And I love this picture, and I really want to talk about this and highlight this, because this is a copepod. This is a tiny microscopic zooplankton. And in the gut here, you can see this fluorescing green. Those are microplastics. So this small animal has been ingesting, is scientifically shown to have ingested microplastics. And I want to talk to you about this food chain here, because if these copepods, which form a huge part of food source and a huge part of the bottom of our marine food webs often, these zooplankton, these black dots, I hope you can see, these black dots are meant to represent microplastics. So these copepods, we're assuming that these copepods have ingested some microparticle, whether it's a fiber or a fragment or a microbead. And then there's two really important words, bioaccumulation and biomagnification. And they sometimes get confused, but bioaccumulation is just over the length of one organism's life. It accumulates because it interacts more and more with microplastics or microparticles or these words are used to any pollutants, but over the course of an organism's life, it encounters more and more, and they bioaccumulate within the organism, especially because microplastics or any plastic, they can't be digested. So if they can't be passed through the organism, they just kind of end up staying in the stomach of these animals, and they can cause what's called false satiation. So they think that they're full because their stomach is telling them that they are, but they're not getting any nutrients because it's just full of plastic. And then as we move, so that's bioaccumulation. As we move up the food chain is where we get into biomagnification. So this is really showing you biomagnification. As smaller fish eat those zooplankton, the microplastics just get transferred from one gut to the other because the organic material can be digested, but the plastic cannot. And then as larger fish, like tuna in this case, eat smaller fish, they magnify more and more and more. So at every food level, you're increasing the amount of plastics because it is just transferring from one organism up the food chain. And then you get to an apex predator like a shark, this case is a hammerhead shark, and you can kind of see all those many black dots. They may look like stripes on your screen if it's really small, so I apologize if that's the case, but these little black dots are the biomagnification of those microplastics over time. So a lot of heavy impacts, but there's lots of room for understanding and for study. And I really wanted to touch on these because a lot of these ways, we know that marine organisms are eating microplastics and other plastics in general, especially like sea turtles. But it may not have been clear like all through the food chain why it's a problem. So I definitely wanted to share that. And thanks to Save Our Seas for this really great infographic. So before we get into innovative research, I'm going to just take a break really quickly, and we're going to touch in and see if we've had any awesome questions. So Hannah asks, have you ever went snorkeling or scuba diving to check out the marine life? And yes, I have. I'm a certified scuba diver. I have an advanced, oh, I can't think of the word. Oh my gosh. Certification, sorry. I'm an advanced certified scuba diver, and I'm also a scientific diver. I have a coral restoration specialty. I really enjoy scuba, and I encourage you guys to get involved. There's a lot of really great scholarships. There's some awesome funding out there. If you're interested and you feel like you can't afford it, definitely, if you're a woman diver, check out the Women Diver Hall of Fame. They have some incredible scholarships, and there's some incredible people that I know that are wonderful mentors in that society. So I definitely encourage you to check there. But snorkeling and scuba diving are recreationally ways that I got into marine science. So definitely check out those. And there's scholarships, like I said. Okay, so that's it for questions, I think. What is my favorite marine animal? Oh, okay, Hannah, let me tell you. My favorite marine animal is actually nudibranchs. It's not one animal, it's a genre, I guess you could say, of animals. And you can actually hear more about them if you check out last week's webinar. Our director, Valerie Paul, has done a lot of work with them. So if you're interested in nudibranchs too, make sure you check out that last one. So I want to talk about, I'm just reading over the questions. Okay, great. So we'll save a couple of those for the end because some things I'm going to address. Make sure that if you're submitting questions, you're submitting them to the Q&A and not to the chat, just as an aside. And our other educators are going to be sending them to me. So if you're sending them in the chat, they may get passed over, but please make sure you're putting them in the Q&A. All right, so now I'd like to share with you guys a little bit more about the innovative research that is happening. Obviously, in such a short amount of time, and I want to make sure we leave room for questions, we're not going to be able to get to all of these, but I really do want to touch on a few that are important. So let me go back to sharing my screen with you. Cool. So innovative research. The one picture that I have on this screen I think is really interesting because this work is coming up at the Smithsonian. One of our researchers, Holly, who is actually on, she'll be presenting her career in a couple more weeks in July for our Career Dive series, so stay tuned for that one. But her work, she's going to be a co-investigator with a couple other collaborative research institutions in Florida, and they're going to be looking at the biofilms on microplastics and microparticles. And what is a biofilm? So we talked a little bit about biofouling and the impacts, but this picture here shows you, imagine that this square is the surface of a microparticle or microplastic. It gets into the ocean, it's kind of like naked, there's not any necessarily biomatter on it. Well, you know, that's not actually true. There's terrestrial biomatter on it, and there'll be matter on it from the entire sewage process. So I take that back. It has a biofilm. It might look different as it moves into the marine environment. So plankton, free-floating bacteria will start to colonize that surface, and they may boot out other bacteria. They may start growing, and then some of these attached bacteria will start to develop, and they will outcompete some of that free floating. And then as that plastic resides in the marine environment, the longer it's there, the stronger that biofilm community is. And the issue with this, or the things we want to understand about this, is how do those biofilms, how are they interacting with the plastics, and also how are they making you know, plastics tastier? As if you were an organism and you came across this microplastic and it kind of tasted the way that it should, like your other food does, because it's been in the environment for so long and it has accumulated this bio community. Like, does it taste like your normal food would, and would you be more likely to ingest it? And so the Smithsonian Marine Station and partners are going to be looking at, you know, what are the micro communities on these plastics, and specifically how they react, how they're affecting oyster communities. And I'm really excited about this work. It's a really awesome opportunity. And like I said, stay tuned for more about that. There's also some really cool and very innovative research happening all over the world. In Canada, OceanWise is a part of Vancouver Aquarium, and they're working to understand microfiber pollution. So we know that microfibers are a huge problem. They're one of the largest forms of microplastic, to my experience and knowledge. And we want to understand, like, how do they get there? What does that look like? How can we reduce it, and at what levels? And we want to make sure that we're not just addressing plastic at a consumer level. We want to start addressing it at industry level with these larger scale policies. So they're doing some really cool work on that. If you're interested in microfibers, I definitely recommend checking out their lab and what they've been working on. They look a lot at the Arctic too, which is really cool. And then there was another, a young student who looked at designing a new treatment for wastewater treatment plants. So that's what WWP stands for, wastewater treatment plant. So they looked into using a ferrofluid as a step for making sure we're addressing microplastic pollution at wastewater treatment plants, since that's like one of the largest streams of how it's getting into the ocean. There are so many other incredible innovative researches happening, and I encourage you to do some Googles if you're interested, because it's a complex problem, and it's definitely going to take more than one action to get it addressed. And I think the more creative ways and we can think about this, the more change that we can make. I'm gonna share with you, if you're curious, and I know a lot of us are, like, what we can do at home. A lot of us ask, how can we help? I'm gonna talk about this slide a little bit, and then we're gonna take some more questions. So we talked about microbeads, and the big thing you can do, even though technically companies aren't supposed to be using microbeads, sometimes they're not always held accountable to that. So a good rule of thumb is when you're purchasing cosmetic products is that you flip it over the back and have a look at the ingredient list. And if you see any of these ingredients, polyethylene, polypropylene, a lot of the times the chemical names are so long that they're abbreviated. But these ingredients in your cosmetic products are going to be microbeads. They're going to be plastics. And it's not going to say on there plastic microbeads. It's going to have the chemical name. So keep an eye out for these when you're shopping for new products. If you can, try and shop in zero waste. And I love my shampoo bar, like honest plug. If you can get a shampoo bar too, I definitely recommend it. It doesn't even have a plastic bottle. We also, we talked about microfibers coming from the washer machine, right? So consider using a washing machine. If you're very passionate about this and you want to make a small investment, there's a couple different brands of machine filters that you're like aftermarket and you can attach to your washer machine. Like I said, they are a little bit of an investment. And it'd be great if at an industry level we started seeing these more and more coming with when we purchase a new washer machine, if they came with a microfiber filter. I mean, wouldn't that be great? But we need policies to show why, like we need to demand it basically. But if you don't want to spend this investment, or if you can't spend this investment, I totally understand. But there are two other more affordable options if you really, really are like, what can I do at home? And those are washing bags. The main one on the market now is called Guppy Friend. Definitely check that out. There's a laundry ball called Cora Ball, and those are supposed to reduce microfibers getting into the sanitary stream at a consumer level. So if you're really passionate and you really are like, I want to make sure that I'm addressing this issue, these are the three things at home that you can do for the washer machine. And then there's two big things I want to talk about that aren't necessarily microplastic specific, but they are really, really important. And the first thing is just to reduce your household plastic consumption wherever possible. So if you refuse single-use plastic items or refuse single-use plastic whenever you can, you're going to want to reduce the amount of plastic that you are using at home, and then reuse it. It used to be reduce, reuse, recycle. Recycle has been shown that it's not the greatest way to solve the plastic problem. If we can just refuse plastic whenever we can, so it doesn't go out there into the environment. And also, I just want to kind of add, like, your vote matters. So if you care really strongly about this, your government leaders at a local, state, national, federal level, it's important that they also care, because those are the people that are enacting these policies, enacting this legislation. So I just wanted to do a plug that your vote matters in a lot of other ways as well, but it also matters for plastic pollution. Okay, so, and last but not least, this is all about progress and not perfection. If you can make one small change to your daily routine that is reducing the plastics, you're doing great. You don't have to be like a zero waste guru influencer on Instagram. Like, if you are, that's amazing, and thank you for the work that you do. If you're not, I'm not, it's totally fine. Just make little baby steps in the right direction. It's about progress. It's not about perfection. Okay, so that is kind of it for me, and let's take some questions. So, Isabel, thank you so much for asking your question. You wanted to know if microbeads from small rocks or pebbles, if you can get microbeads from small colorful rocks or pebbles. I don't think so usually. Sometimes you have to be careful with like aquarium rocks when you purchase them. Sometimes those rocks have been coated in like plastic or coated in paint. So you definitely, if you purchase something for your aquarium, please don't put it out in the environment. Those, if they are colored, they need to make sure that they stay in your home, or if you're done with them, you can dispose of them. But don't put them back on the beach. That's a great question. Thanks, Isabel. So Phil would like to know, can we talk about the study that found chemicals leaching from microplastics? Can it inhibit the photosynthetic production of cyanobacteria? Phil, also really great question. That's not my area of expertise, but I would encourage you to take to Google Scholar and really ask that question and see what the researchers have said. I'm not an expert in all areas of chemical leaching, and it's, like I said before, it's a kind of a new field of microplastic research. But it depends on the amount of, just to briefly answer your question, I don't want to disregard it, and I hope that this maybe will point you in a direction, but chemicals leaching from microplastics, it depends on what chemicals are in the environment and where they have been absorbed by the microplastic. And then if they're leaching into the cyanobacteria that are growing on the biofilm, I mean, my assumption would be like, yes, they probably are if the microplastic has absorbed them. What that impact looks like, I can't say, because that's not, again, my area of expertise. But really great question. Definitely an area that could be looked at. And I can pass that over to Holly and see what she says. Okay, great questions, guys. Are microplastics excreted after ingestion, and have microplastics been found in humans? So the answer to excretion is sometimes. There's a lot of really interesting work going on with sea turtles. Some of the sea turtles can pass the plastics that they've ingested. They're not always small pieces. If you follow Loggerhead Marine Life Center, you'll see that some of them are actually quite large. So it depends on the size of the pieces that are ingested. Maybe this is too much information, but the mouth of many animals is usually larger than the anus. Not always, but often. So things that are coming in might be larger than what can be passed. And that's because usually you would be digesting that material and it would take on a different shape and texture. So I think it's an interesting question. Some microplastics are excreted. To what extent, I'm not sure, but and yes, they are found in humans. So we drink them, we eat them, we breathe them in dust. Because plastic is such a commonly occurring material, it's really everywhere. So for sure, I don't have the answers on like what amount. There's been studies that have shown that we ingest like a credit card size amount of microplastics. It might actually be more than that. But for sure, humans are getting microplastics. So we have another great question. Many companies tout their environmentalism by recycling plastics into garments. Is this just speeding the degradation to microplastics? That's a really great question, and it's definitely something that we won't have time to get into all the nuances today. There's a lot of greenwashing, and all that means is that people say that things are repurposed and recycled, and they're not very transparent about how that's actually being done. A lot of the time, those garments come from water bottles, and they're not from the ocean. They're clean water bottles that are a single stream, and they've been turned into garments. Yes, I guess you could argue both ways, and I'm going to give you this, just to be clear, is my personal opinion. The issue with that is like we're taking the plastic that may have been one thing and we're turning them into something else. So I think in terms of reusing, it's a really good alternative, but I definitely encourage companies like that to be a little bit more transparent. One of my favorite companies, if you're curious, that is taking marine debris and turning it into something awesome is a company called Beur. They have a direct partnership with South American fishermen to turn their what would have been discarded ghost nets in the oceans into skateboards and games. And I think it's really, really super awesome. And I really encourage more companies to start pursuing that as an alternative. Okay, my friends, so I will take one more question, I think, because we're getting on to the 40 minutes. But Phil asks a great question. Is there work being done to improve the filtering of water treatment plants to capture microplastics? Phil, that is a great question. And it is something that is definitely being researched. Again, I have some friends up at Oceanwise in Canada that are looking at wastewater treatments and exactly how much microplastics is coming from them and what that looks like in their effluent. I think, again, personally, a lot of the wastewater treatment plants infrastructurally haven't been updated to include filtering for microplastics. Tertiary wastewater treatment plants don't have necessarily the ability to do that, especially because they're so small. So I think, again, policy needs to change regarding that. Maybe making some funding available to start investigating that, to start researching it. I think the capability is definitely there, but we need to kind of demand change, right? Like we need to address maybe washer machines having these filters just built in, like everyone at home needs to have this filter. Maybe, you know, addressing it at a wastewater treatment level, because there's only so much consumers can do. And I really feel like a lot of the pressure and, you know, reducing your plastic gets put on consumers and on us. But the biggest changes can happen at an industry level, but they're not going to happen unless we start demanding change. And I just really want to maybe leave you guys with that. Thank you so much for joining in today and for listening to me ramble on about my story and how I got into microplastics and into marine debris work. If you enjoyed today's segment, please make sure that you join us next week, next Thursday at 10 a.m. Katie Skura is going to be talking to us about how she got into aquaculture. She's our aquarist here at the Smithsonian Marine Ecosystem exhibit. And you can learn a little bit more about how to get into husbandry and what another person's journey looks like. So thank you guys again for joining us. If there's any further questions, you're welcome to reach out to us on Facebook. You can follow us at Smithsonian Marine Station and Ecosystems Exhibit on Facebook. We're going to be posting a live stream there, and we'll be posting the links if you came in late and didn't catch some of it, or if you want to share it with your friends. Thank you so much again for joining us. It's been my pleasure to speak to you guys about microplastics today. And that's all from me. Thanks, guys.